Okay, so today we're going to continue with chapter 6. So what do we have in chapter 6? Now let's see. So previously we have seen how to do the unit conversions as well as how to calculate the net force and also the centripetal accelerations. Okay, net centripetal force and centripetal accelerations. So today we're going to see how to apply centripetal force in three different cases. The first one is horizontal circular motions. The second one is a vertical circular motions, and then the last one is the conical pendulum case. Okay, so we have I think 7 questions to be discussed today. So first, let's look at the questions 4. Questions 4, now you have a car of mass 2000 kg. So this one is your mass. Rounds a circular turns of radius. Now this is R. So the road, okay, the road is flat. And the coefficients of frictions between tires and the road is a 0.70. So now, what is this value? This value is a mu, coefficients of kinetic friction, okay, which tell us in these questions, now there is a frictional force. Okay, in the diagrams given, now there is a frictional force. And of course there is. Why? Because frictional force is a force that keeps our cars to move in a circular track. Okay, it won't run from the desired path because of the frictional force between tires and the road. Okay, so questions A, sketch a free body diagram of the car. So how to sketch a free body diagram of the car? You look at the diagrams given and then you try the things. Now you have a car. Okay, let's say this is your object. Okay, this is your object. Now it's up to you whether you want to have the view from the front or from the backs of the car. Okay, the front view or the rear view. So the important thing is remember to label the directions of AC after this. So first you look at this diagram. Car is an object. This object, it comes with weight. So you have W that is going down. Okay. And then it is moving on the road. Okay, so it is in contact with the surface of the road. Therefore, there's another frictional force that not frictional force. Okay, normal force. Okay, normal force that is going up. So you have a normal force that is going up and a weight that is going down. Then how about frictional force? So assume I'm viewing it from the front, okay, because I like to view it from the front. So the front, then I have a frictional force that is going towards the center. So F is going towards the center. Now, how do I know whether I got the correct diagrams or not? Well, you just remember to put AC outside the diagram to show the examiner, to show the reader that this frictional force is now pointing towards the directions of AC. It is in the same direction as your AC. Okay, so you have F that's going towards the center. So AC is also going towards the center. So that is the answer for questions A. You have free body diagrams, and then I put F going to the right because that is the directions of my AC. Now, some students, they ask me, can I put the frictional force to the left-hand side? Yes, you can. Just remember to show the directions of AC so that the reader knows your frictional force is parallel to the AC and it is pointing towards the same direction as your centripetal acceleration. All right, so that is your questions A. Now, questions B, determines the maximum speed of the car without skidding. So the reasons why it can move in the desired circular motion, that is because of the frictional force. Okay, and it is also because the speed hasn't exceeded the maximum limit yet. So this question, it wants us to calculate the maximum speed of the car. So how are we going to calculate? So we want to find out the value of V when it is no longer moving in circular motion. So first we want to identify which axis involves circular motion. So according to my free body diagram, apparently it is the X component. So circular motion is happening along the X component. So now I'm going to expand the equations. All right, I'm going to expand the equations. So first, okay, B. So summations Fx is now equals to my Fc because that is where I have circular motion.
There.
Yeah, apa? Hah? Apa? Tak dengar. Q cakap apa?
Lagi slow ke?
Line slow. Line saya slow atau line kamu yang slow?
Ada lag itu. Ke aku yang lag.
Oh, saya punya lag. Semua orang nang tengok lag kah? Saya pun tak pasti siapa yang lag.
Madam okey je. Madam tak okey je.
Saya yang lag.
Tak.
Madam okey je.
Oh, saya punya okey. Okey, kalau begini saya proses saja. Anda kena fikir macam mana tak lagkan Anda punya screen. Okay, now summations fx equals to fc, and then it is equals to mac. Okay, so remember A should be centripetal accelerations. So centripetal force, you use centripetal accelerations. Linear force, you use linear acceleration. So Fc equals to mac. Now, if you look at my free body diagram, the force that causes my object to move in a circular motion is just a frictional force. Therefore, I'm going to expand these equations to F equals to mv squared over r. Okay, the reasons why I change it to v squared over r, that is because the question is asking for speed. So I need to have speed in my equations. But then again, if you look at the questions, now I don't have frictional force, but what I do have is the mu, coefficients of friction. Therefore, I'm going to expand these equations one more time. So now I have mu n equals to mv squared over r. Aha, so can I solve it now? So you look at the equations again. I think not yet, right? Why? Because I don't have n. So how can I find n? How can I determine the values for n? So look at the free body diagram. So according to free body diagram, I have a normal force going up. And the force that is parallel to the normal force is weight, which is going down. And there's no motions along vertical component. Therefore, I'm going to apply Newton's first law. Summations Fy equals to 0. So along this vertical component, I have two forces, one going up and the other one going down. So what am I going to do? I use n minus w equals to 0. Okay, so rearrange the equation. N is then equals to mg. From here, I can then determine the values of normal force. So which is equals to 2000 times 9.81. Okay, 2000 times 9.81. So which is then equals to 19620 Newton. So I'm going to substitute this value into the first equation just now. So mu is a 0.70 times 19620 equals to 2000 v squared over r is 20 meter. So rearrange the equations, you will then obtain v is equals to 11.74 ms negative 1. So that is the answer. Okay, that is the answer for questions number 4. So now I give you some time to write it down, okay, including the free body diagram. Make sure you know how to sketch free body diagram because it's very useful. It tells you which force involved in the circular motion, which force caused the object to move in the circular motions. All right. So 1 minute for you to write it down. Okay. So first question is very simple, just that students usually they overlook, okay? They can relate frictional force with the circular motions. Now you just have to remember, frictional force actually is the force that causes us to move forward, okay, to move forward. So it can cause us to move in the circular motions, and usually it causes us to move in a straight line. So even when you're walking, the reasons why you can move forward, that is because of the frictional force between you and the floor, between your legs and the floor. Okay, so it prevents you from slipping. Okay, so just like it prevents a car from skidding. Therefore, cars can move in the circular motions and you can move forwards. Okay, so that is your questions 4. Okay, that is your questions 4. So now let's look at questions 5. Questions 5, now you have a ball of mass 150 gram. Now you have a non-SI unit. So to make it easier, okay, when you read the questions, when you write out the information, straight away you change the unit. So M is equal to 0.15 kg. Okay, M is equal to 0.15 kg. And it's attached to one end of the string, which is 1.1 meter long. Okay, siapa terbuka mic dah? Mic Sarah? Okay dah?
Sorry.
Okay. So kalau ada soalan boleh tanya. Okay, now you have strings of 1.1 meter long. So if you look at this circle, the string is actually from the center to the ball. Okay, which means in this case, the length of the string, actually it represents the radius of the circle. So this is our R. All right, so even though it is the length of the strings, okay, it seems that the symbol is L, but then in our diagram, it represents the radius of the circle. So the ball makes 2 revolutions per second. So what is this? So you have revolutions per second. Obviously, this is our omega, okay, in a horizontal circle. So sketch a free body diagram for the ball. So this is the ball. Okay, now it's located on the right-hand side of the circle. So this is my free body diagram. Now, ball is an object. Every object comes with a mass, okay, come with a weight. So you have a weight that is going downwards. And then it is being attached by a string. Therefore, it has a tension that is going to the left-hand side. And to make it clearer, to make the examiner knows that tension is not just a one direction, it follows the directions of AC, then therefore we put AC outside the diagram. Okay, directions of AC outside our free body diagram to show that tension is always pointing towards the directions of AC. So that is questions A. Okay, that is questions A. So questions B, the centripetal accelerations of the ball. So how are we going to calculate the centripetal accelerations? First of all, we try to write down the equation. So B1. So the equations for AC, we know according to the definition is V squared over R. But if you look at the questions, the information given is omega. Okay, and how are we going to add omega into our equations? Well, we can transform V into omega by using V equals to R omega. Therefore, AC at the same time is equals to R omega squared. But then we got one more questions. 2 revolutions per second is not SI unit. So what are we going to do? We want to convert the unit. So omega equals to 2.0 revolutions per second, okay, per second. So we want to change it, we want to transform it. Let's make it into fraction form first. It is 2 revolutions over 1 second. So 2 revolutions, we know that is 2 times 2 pi radian. Okay, so over 1 second. Therefore, omega is equals to 4 pi radian per second. So that is the omega. Okay, that is the omega in questions number 5. Now we have a omega in SI unit. We can then sub it into equations. So A equals to R omega squared, which is then equals to R is 1.1, and then 4 pi squared. So press your calculator, you will then obtain 173.7 ms negative 2. Okay, 173.7 ms negative 2. And because acceleration is a vector quantity, so you need to state the direction. So what is the directions? Always toward the center. Okay, unless the question asks you to calculate the magnitudes of centripetal accelerations, then you don't have to state its direction. So that is questions 1, okay? Questions B1. Now, questions B2. B2, it asks you to calculate just the magnitude. So now you don't need the directions, yes?
Towards the center is ke depan daripada ni lah. Ke depan daripada pusat lah maksud dia.
Tak ada, dia menunjuk ke pusat bulatan. So pusat kita di sini. This is a center, okay? This is a center di sini. Okay. So it doesn't matter where is your object. The directions of AC always towards the center. So kalau objek kamu di belakang, AC ke depan. Objek kamu di sini, AC ke sini. Objek kamu di depan, AC ke belakang. So that is the meanings towards the center.
Okay, thank you, madam.
Right. So now let's look at questions number 2. Questions number 2 asks you to calculate the magnitudes of tension. So the magnitudes of tensions, how are you going to calculate? Let's go back to free body diagram. According to free body diagrams, I have a tension. Okay, I have a tension, and tension is going to the left. And it is in the same direction as my AC, which obviously is a force that causes my object to move in circular motion. Therefore, I'm going to use summations Fx equals to Fc, the centripetal force equals to MAC. So along the x component, I have only one force, which is tension. Therefore, T equals to MAC. So mass given is 0.15 kg, 0.15 times A, 173.7. So which is then equals to 26.06 Newton. So you don't have to state the direction because it's just asking for magnitude. Now, if the questions want you to state the direction, then what is the directions? Also towards the center. Okay, because it is the force that causes your object to move in circular motion. Therefore, it is in the same directions as AC. So AC is towards the center. T is also towards the center. So that is questions number 5. All right. So again, I give you 2 minutes to write it down, okay, on how to solve these questions, especially in terms of unit. All right. This question is tricky because you got various unit. You got gram, you got revolutions per second. So before you solve the questions, you need to make sure all of them, they are in SI unit. Okay, so give you some time to write it down before we proceed to next questions. Right. So let's proceed to the next questions. Questions number 6. Okay. Yeah. Okay. Questions number 6. How are we going to solve this question? So this question is a bit tricky. Okay, it's very similar to the previous questions, but then now you swing it on a surface. So a ball of mass 0.3 kg is attached to the ends of a horizontal quartz. Okay, and it's rotated in a circle of radius on a frictionless surface. So now you swing it on a surface. Okay, so it's very similar to the previous questions, but now the difference is you place it on the surface and then you swing it. If the cord will break when the tension exceeds 80 Newton, so given T is 80 Newton, this is T maximum. Okay, T max. Determines the maximum speed of the ball. So first of all, let us sketch a free body diagram. So now you have a ball. Again, a ball comes with a weight. All right, and then you tied it to a ends of a horizontal cord. So you have a tension. So this is basically, now this is a surface, right? And then this is the ball, and then you tie a cord, okay, tie to the end of a cord, and then you swing it. So this is a cord. Okay, so basically this is what we have. So now you place the object on a surface. Okay, this is a surface. So which means it's going to have experience a normal reaction force that is going up because it is in contact with another surface. And how about the tensions? The tension is lying on the horizontal because you tied it to a cord and the cord is making it to swing in a circular motion. Okay, to move in a circular motion. So now that I have a diagram like this, and then the AC is always pointing towards the center. Okay, it's always pointing towards the center.
Madam, kod
Yes.
apa dia?
Dia macam
Kod.
satu batang benda. Okay, dia satu tali. Okay, kita tali. Kamu
Tali,
punya macam kamu punya gitar punya chord semua itu.
Oh, okay.
Okay, so kamu ikat dia pada hujung bola and then you swing it. Okay, you swing it. So there's a tensions. Okay, there's a tensions. So on a frictionless surface, if the cord will breaks when the tension exceeds 80 Newton, so determines the maximum speed of the ball. So tension is happening along the x component, which means now what are we going to do? If you look at the free body diagram, x component involves the circular motions AC. So summations Fx is 1 again equals to Fc, which is then equals to MAC. You want to find the speed, so you need to expand the equation. And if you look at the free body diagram, I have only one force along the x component. Again, it is a tension. Okay, so tension T, now T maximum is then equals to mv square. Now this V, okay, mv square of r, this V, it should be maximum V as well, the maximum speed. Why? Because if you look at this equation, T and V, they are directly proportional to each other. Okay, T is directly proportional to V. Therefore, when T is maximum, V is also maximum. That's why we use maximum tensions, XT, to calculate, to determine the values for maximum speed. So T max is equals to mv max square over r. So T max is XT equals to 0.35 and then times with the V max square divided by R. Okay, your R is 1 meter. Okay, your R is 1 meter. Okay, now what next? So rearrange the equations, you will then obtain V max is equals to 15.12 meter per second. Okay, 15.12 meter per second. And then next, how to calculate the period of the ball. Okay, next we want to calculate period, right? So if you look at these equations, T max is equals to mv square over r. So how are we going to calculate period? Which equations can give us period? Aha. So let's start from V. Okay, so previously we have seen, okay, previously we calculate quite often, we use the equations that we use period quite often is omega. We say omega is always equals to 2 pi over t, right? That is what we use quite often yesterday. So from omega, we can then link it to our velocity, okay, where v is equals to r omega, which is then v is equals to r 2 pi over t. Now there is our period. So you want to find minimum period. If you look at this equation, what happens between period and v? So obviously now you have v here, your period is here. They are inversely proportional. Okay, so you have a v is inversely proportional to t. Therefore, when your v is maximum, t would be minimum. Okay, t would be minimum. So sub the value into the equation. 15.12 equals to r is 1. And then 2 pi over t. Rearrange the equation. T is then equals to 0.416 second. Okay, so this is how you calculate the maximum and the minimum value. All right, so again, I give you a I gave you 2 minutes to write it down. Okay, I give you 2 minutes to write it down. Okay. So make sure you know the relationship, because relationship is very useful in explanation question. Okay, this relationship dia sangat-sangat penting dalam explanation questions. Sometimes it will ask you what happens if you increase the tension. Then you will see what happens to the velocity. So based on the equation, they are directly proportional. So when you increase the tension, V will increase. Okay, and then sometimes it might ask you what happens when you increase what happens to the period when you increase the tension. So you have to do the two-step comparison. Right? So this is how we answer explanation question. Dengan menggunakan highlight yang warna hijau ini. So kita explain dia. Okay, kita explain dengan guna benda yang warna highlight hijau, warna hijau ni. So relationship is a must in explanation questions. Oh, satu lagi yang senang nak faham apa itu cord, kamu punya cable cord. Okay, kamu punya semua cable yang kamu pakai itu pun panggil cord. So dia is a string like item. Okay, so next. So now we are done with the horizontal circular motions. Okay, we only have 3 examples in the horizontal circular motions and 3 examples on the vertical circular motion. So this is the first question for a vertical circular motion, where your object is moving in a vertical circle. So a sphere of mass 5 kg, this is your M, is tied to an inelastic string. It moves in a vertical circle of a radius. Now radius, again, you have it in cm, so you change it into meter. So which is r equals to 0.55 meter. At a constant speed, so you are given v equals to 3 ms negative 1, as shown in figure. By the aid of a free body diagram, determines the tension in the string at point A, B, and C. So it wants you to show the value at 3 different positions. So how? Let us begin with free body diagram. Okay, so at point A, which is here. So at point A, now this is a sphere, okay, an object. Every object, it comes with weight. So we have a weight that is going down. And then now there's a string, okay, the string is this dotted line. This dotted line, this string is located behind the below the object. Therefore, you have a tension that is going downwards as well. Okay, so both W and T, they are pointing downwards. And what happens to the centripetal acceleration? When your object is at positions A, AC is going down. Okay, so you put it outside the diagram, AC is going down. Therefore, we know that both T and W, they are the force that causes my object to keep moving in circular motion. So now let us solve it. Okay, let us solve the questions to find the tension. So summations fx, oh no, this is not summations fx anymore. This is your summations fy. Okay, summations fy along the y component, it is equals to your fc at positions A, and it is equals to mac. All right. So Fc equals to mac. Now the force that causes my object to move in a circular motions, or we say the force that is pointing towards the same directions as AC or parallel to AC, okay, is a W and T, right? So both of them, they are pointing towards the same direction. So W plus T equals to mv square over r. Okay, again, I expand it to mv square over r. Why? Because the information given is velocity. Right, the information given is velocity, which is equal to 3 meters per second. Now W, I don't have W, but then I can calculate W. Therefore, mg plus t equals to mv square over r. So now I'm going to plug in the value. M is 5, g is 9.81, plus t equals to 5, the radius is 0.55, and then divided by r, which is, v is 30. Okay, my bad. So v is 30, so 30 square. Okay, 30 square divided by 0.55. So rearrange the equations, you will then obtain T is equals to 32.77 Newton. So this is the tensions at point A. Okay, tension at point A. So next, we are going to see what happens to tension at point B. Okay, at point B. So again, let us begin with a free body diagram. So at point B, okay. So what happens at point B is now I have a point B. So at point B, the weight of the object is still going downwards. But then now if you look at the diagram, the string is located on the left-hand side of the object, which means my tension is now going to the left. Okay, and according to the diagram, okay, the AC is also going to the left because the center is located on the left-hand side of the ball. So AC, I put it outside the free body diagram. So AC is going to the left. So that is my free body diagram for object located at point B. So again, I'm going to calculate it now. So now it's along the x-axis. Therefore, summations Fx is equals to, Fc first. Okay, we need to use the Fc. So summations Fx is equals to Fc. Okay. So which is then equals to MAC. So Fc, now the force that is lying on the x component is just the tension. Therefore, T is equals to mv square over r. Plug in the value, I have 5 and then 30 square divided by 0.55. Therefore, tensions at point B is just equals to 81.8 Newton. Okay, 81.8 Newton. So this is a tension at point B. Then how about tension at point C? Okay, so at point C, again, we need a free body diagram. So free body diagram. Now, point C, again, it is a sphere and it comes with a weight. Therefore, weight is going down. But then according to the diagram, now yes?
V dia 3 kan?
3. Oh, 3.0. Saya termakan titik itu sebab lapar. Okay, so 3.0. Okay, so kita padam kosong. Okay, so it should be 30. Sorry, it should be 3.0. So at point C, the weight is still going down. Okay, the weight is still going down. And then the tension is now located above the object. Therefore, I have a T that is going up. According to the diagram given, my AC is now pointing upwards. Okay, it's going up. Okay, therefore I have AC that is going up. Okay, now why is it important to have AC? This diagram, it shows you clearly, okay, this free body diagram. Why? Because we are going to take the directions of A as positive direction. AC is going up. Therefore, I'm going to take upward as positive and downward as negative at point C. Okay, at position C. Okay, so now I'm ready. Okay, I can now form equations. Summations Fy is equals to Fc, which is then equals to MAC. Fc, now according to my free body diagram, I have two forces that is parallel to AC. Okay, one going up and one going down. They are pointing towards opposite direction. So which means we need to subtract them. How to subtract them? You look at the directions of AC. AC going up means T is a positive value. So T minus W equals to mv square over r. Okay, so T minus mg equals to mv square over r. Then what do we have? Okay, we then sub the value into the equations. T minus 5 times 9.81 equals to 5 and then 3 square over 0.55. T is then equals to 130.9 Newton. So based on this three value, okay, what can you say about this vertical circular motion? So according to this three value, the string, the cord, will experience maximum tension at its lowest position. Okay, because it gives you the largest value, T, which is equal to 130.9 Newton. compared to at the top at point A, which is just 32.77 Newton. So the string experienced the least tension at the highest position, and it experienced the most tensions, the maximum tension at its lowest position at the bottom of the vertical circular motion. Okay, so now this one is a bit long. I give you 3 minutes to write it down. Okay, 3 minit bagi anda tulis, and then boleh juga buat catatan posisi mana dia ada maximum tension. Right, because sometimes questions will ask you to determine the positions that where object experience a maximum tension or least tension. So 3 minutes for you to write it down. Okay, if you're done, you may try the next questions, yeah? All right, next. Okay, so this is also a vertical circular motions example. Okay, but now so you have a Ferris wheel, okay, with people sitting on it. So a rider on a Ferris wheel move in a vertical circle of radius r equals to 8 meters at a constant speed v, as shown in the figure. So if the time taken to make one rotation is 10 seconds, now what is the meaning of this sentence? The times taken to make one rotation, okay, which tell you that this 10 second is capital letter T. Okay, capital letter T. Why is it important to know that it is a capital letter T? Because it lets you calculate the omega. Okay, it lets you calculate the omega. So the mass of the rider is a 60 kg. So this is M. Calculate the normal force exert on the rider. So you want the information about the person sitting on the Ferris wheel. Not the whole Ferris wheel, yeah? Not including the cage. Okay, now how are you going to calculate? First of all, okay, if you look at the informations, you have R, you have M, and then you have capital letter T. The most important thing in this chapter 6, you don't have it yet, which is the V or omega. But then you are given tension, you're given tensions, you're given period. Okay, you are given capital letter T, which is period, which means you can calculate omega, where omega is equals to theta over T. If your theta is equals to 1 rotation, 1 revolution, then it is equivalent to 2 pi. So the times taken to complete 2 pi is 10 seconds. Okay, your capital letter T. Therefore, it's 2 pi over 10. So omega is then equals to 5.3. Okay, wait, yeah, 2 pi, 0.2 pi. Okay, so from here you can then determine the V. Okay, determines the V. So we change it into V to make it easier. So V equals to R omega, which is then equals to 8 times 0.2 pi. Okay, so V is then equals to 5.03 ms negative 1. So it is up to you whether you want to use omega or you want to use V. Okay, it's up to you whether you want to use omega or you want to use V. So the only difference is that if you use omega, then you're going to have Fc equals to m r omega square. If you use V, then you're going to have Fc equals to mv square over r. So eventually you're still going to get the same answer. Alright, so it's up to you which one you want to use. Mana-mana saja, okay? Tak ada salah, tak ada betul. Yang penting kamu guna equations yang betul. Kalau omega, Fc equals to mr omega square. Kalau V, Fc equals to mv square over r. Okay, now let's look at what happens when a rider is at the top of the circle. Okay, so when it is at the top of the circle, now this is a rider. Rider is also an object. Every object comes with weight. Therefore, we have W going down. Okay, and then now it is sitting on a Ferris wheel. It is in contact with a surface. Therefore, you have a normal force that is going up. Okay, normal force that is going up. And when the person is located at the top of the circle, the directions of AC is going down. Okay, AC is going down. Therefore, what happened is that I have AC pointing downwards. Okay, AC ke bawah. So AC going down. Next, what are we going to do? You want to calculate normal force. Normal force is lying on the Y component. Okay, so what are we going to do? Let's see. Y component, we have AC. It means our FC is happening along the vertical component. Okay, kita tengok arah AC. AC along vertical component, then FC you use for vertical component. If AC is along horizontal component, then FC we use horizontal component. So for this case, AC is vertical component. So summations Fy is equal to your FC, which is then equals to MAC. Now, AC is pointing downwards. If you remember what I told you just now, directions of A determines the directions of positive vector. If it's going down, then it means downward is positive. And upwards vector is negative. All right? Therefore, when you expand the equation, okay, now these equations will become W minus N. Okay, W minus N equals to mv square over r. So W minus N, I have mg minus N then equals to mv square over r. And then plug in the value, 60 times 9.81 minus N equals to 60. V is 5.03 squared divided by the R, which is 8 meter. So N is then equals to 398.8 Newton. Okay, 398.8 Newton. Now let's look at what happens if the rider is at the bottom of the circle. Okay, so if the rider is at the bottom, so what happened is that now the rider still have weight, okay, because rider is object. And then it's still sitting on the Ferris wheel. It's still in contact with the surface. Therefore, you have an N going up. But then, if you look at the diagram, if your object is located at the bottoms of the circle, it means your AC is going upward. Okay, so now the directions of AC have changed compared to when it is at the top. Okay, so which means now for questions B, for when your Ferris wheel is at the bottom of the Ferris wheel, directions upwards is a positive directions then, and the downwards would be a negative directions now. Okay, upward is positive and downward is negative now because of the directions of AC, because directions of AC have changed. Okay, so again, it's involve a vertical component. So summations Fy equals to Fc, which is equals to MAC. So Fc now I have what? I have N minus W. Okay, just now it's W minus N. Now I have N minus W equals to mv square over r. Okay, so N minus what? Minus mg is equals to mv square over r. So n minus 60 times 9.81 equals to 60 times 5.03 square divided by 8. So n is then equals to 778.4 Newton. Okay, 778.4 Newton. So when you compare these two values, you will see that when the rider is at the top of the circle, it has a smaller normal force, which means it's going to give you a smaller reading on your weighting scale. Okay, weighting scale. So weighting scale, it gives you a smaller reading when the rider is at the top of the Ferris wheel. But when you're at the bottom, then you will have a larger, much larger reading. Okay, kamu akan jadi lagi berat kalau kamu ukur berat badan di bottoms of the circle. Kalau kamu ukur berat badan di atas, then kamu akan jadi lebih ringan. Okay, akan jadi lebih ringan. So that is your questions number 8. Okay, so I give you 2 minutes to write it down. 2 minutes bagi anda tulis. Okay, catat yang penting kamu tahu bila kamu form equations, apakah perbezaan antara dua equations ini. Iaitu dari segi N tolak W atau W tolak N. Okay. So next question. Next question is very similar to this question, but now you try to observe the diagram. You try to look at the diagram. Where is the object? The object is now inside the circle rather than outside the circle. So a small remote control car with mass 1.2 kg. So you have M, move at a constant speed V. Now you have V equals to 15. So the radius of the track is 3 meters as shown in figure. Determines the magnitude of reaction force. So again, it's asking for N, normal reaction force, exerted on the car by the track at point A and point B. So let us begin with point A. Okay, so at point A, what is the free body diagram? So remote control car is an object. Every object comes with weight. And now it is in contact with the track, therefore you have a normal force that is going up. And when your car is at the point A, the directions of AC is going upward. Okay, therefore AC is going up. So this is a free body diagram. And now we want to calculate the normal force. Okay, the normal force. So how are we going to calculate it? FC equals to MAC. According to my free body diagram, my A is now going upward, which means upward is a positive direction and downward is a negative direction. Therefore, I'm going to write it down as N minus W, because N is a positive vector, W is a negative vector. So N minus W equals to mv squared over r. So again, I write as mv squared over r because the questions give me v. Okay, so N minus mg equals to mv squared over r. So plug in the value, and minus 1.2 times 9.81 equals to 1.2, the V given is 15, 15 square divided by 3 meter. So N is equals to, this one, I think it is equals to a 101.8 Newton. Okay, the answer given is wrong. Okay, the answer given is wrong. So it is equals to 101.8 Newton when your object is located at positions A. Now let's look at what happens at positions B. This is more interesting. At point B, okay, again, remote control car is an object, therefore it's come with weight. But if you look at this diagram, now the track is located above the object. Okay, your object is below the track. Therefore, the directions of normal force, if you remember the definition, it is always perpendicular to the surface. Therefore, now you have an N that is perpendicular to the surface, which means that is pointing downwards because your object is located inside the track. So if it is perpendicular to the track, then it means it's going down. So for point B, for object at point B, your N is also going downwards. So you have two vectors that is going down, one W and one N. And obviously, when it's at point B, your AC is going down as well. So AC is going downwards. Okay, so this question is tricky because of the positions of the object. It's no longer outside the track, but it is inside the track. Okay, it is inside the track. So how are you going to form the equation? Now, since both W and N, they are pointing toward the same direction, and it is same as the directions of AC, so we're going to use, let us begin with a Newton's second law. So we're going to start from FC equals to MAC. So FC is now equals to W plus N, because now they are both pointing towards the same direction and the same direction as your AC. So it is equals to mv squared over r. So W is a mg plus N equals to mv squared over r. So mass given is 1.2 times 9.81 plus N equals to 1.2 times 15 square divided by 3. Normal force is then equals to 78.2 Newton. Okay, 78.2 Newton. So that is the answer for second questions. Okay, now what I want you guys to do, you may add one more diagram, okay, where your object is located outside the track. So now what happened is you have an object that is located outside the track. So what happened now outside the track? So outside the track, what happened is that now you will have another different free body diagram. So if it's located outside the track, W is still going down. But now because it's outside the track, so what happens to the normal force? The normal force is now pointing upward. So on the same track, the only difference is one is inside the track, one is outside the track, then you will have different free body diagram. So if it is outside the track, AC is still going down. Okay, AC is still going down because of the circle, center seeking acceleration. So which means now W is a positive vector and N is a negative vector. So when you form equation, FC equals to MAC, you will then obtain W minus N equals to MAC. If your object is located outside the track, okay, outside the track. So this is an additional diagram for you. Okay, so if you write it down, then you can see what is the difference between point A, point B, and also what happens if it is located outside the track rather than inside the track. All right. So I give you 3 minutes to write it down. Okay, I give you more time because you need to add one examples by yourself. Okay, which is the outside the track. So 3 minutes for you to write it down, and then we'll proceed to next example, which involve a conical pendulum. Okay, a 2D questions. Okay, so kalau ada apa-apa tak faham, kena tanya ya. Sebab example yang kita bincang ini antara example yang senang. Okay, next. So these questions is, I would say, is a hot questions, right? Because it involve a normal chapter 4, the normal Newton's law of motions, and also your circular motions. You need to have a strong concept in both in order to answer these questions. So a bar of mass 1.34 kg is connected by means of two massless strings to a vertical rotating rod, as shown in figure. The strings are tied to the rods and they're taut, so pushing. And then the tensions in the upper strings is a 35 Newton. So T for the upper string, I'm going to call it T1, is equals to 35 Newton. All right. So now let's sketch a free body diagram for the ball. So questions A, so this is the ball. No. Or is an object. Every object comes with weight. Okay, so W. And then according to the diagram, there are two strings that has a direct contact with the ball. Okay, so we try to identify the force that is in contact directly with the object. So in which now is a tension. So I have a tensions T1 here. And then tensions T2 going towards the other direction. So this is the horizontal component. And then this is a vertical component. Now, I know both tensions, they have different value based on my free body diagram. Why? Because I have an additional force that is going downwards, which tell me that T1 and T2, they don't have same value. So I need to label T with subscript 1 and 2. Because they don't have same value, you cannot just leave it as T. Okay, kamu tak boleh biarkan T saja. So how do I know that they are not the same? Well, if they are the same, then we wouldn't have a W here. Okay, we wouldn't have W here. So the reasons why I know they are different because of this W. This W tells me that now T1 and T2, they are not equals. They don't have a same value. Okay, they are unequal. Okay, so free body diagrams, now I have it. And then what is the directions of my A then? So if you look at the diagram, obviously the A would be pointing towards the road. Okay, it's pointing towards the road. So road is the center. Therefore, my AC is going to work this direction. Right, so free body diagram now done. Okay, T1, T2, and W. Now let's look at questions B. Questions B calculate the magnitudes of the tensions in the lower string, which means it's asking for T2. Now, in order to calculate T2, can I use x-axis? Obviously cannot. Why? Because I don't have enough information. The information given is just a mass and then the tension for the upper string. But I don't have the information about the accelerations, about the velocity. So I cannot use x component to solve it. Right? So what am I going to do? Okay, I'm going to use y component. So down there is no motions along y component. Okay, AC is not located on the vertical component, and there's no motions along y component. Therefore, I'm just going to apply Newton first law. So summations F equals to 0. according to my diagram, if I resolve T1, then I will have T1y going up and T1x going to the left-hand side. And then if I resolve T2, I will have T2y going downwards and T2x going to the left. Okay, this is what happens if I resolve it. Okay, if I resolve T1 and T2. So now if you look at the free body diagram, how many forces do I have along the y component after I resolve it? Well, I have T1y, I have T2y, and I have W. T1y is going up and the other two, they are going down. Therefore, I'm going to expand the equations into T1y minus T2y and minus W. Okay, because T2y and W, they are pointing downwards, which is then equals to 0. Now, the next questions would be, I don't have the angle. Okay, I don't have the angles of the tensions. But what I can do, let's go back to the diagrams given. So let's say this is a horizontal line. Now, the things that I'm missing is the angle. Okay, it's this angle. And because T1 and T2, both of them, they have the same length. Okay, so which means they will have the same height as well. Right? So this one would be 0.85 meter. Here would be 0.85 meter. Right? Because tensions 1 and tensions 2, they have same length. So which also means that they will have the same angle. Right? They will have the same angle. Now that I have the T1, the length, okay, the length for upper string and the lower string, and also the height. So if you look at the diagram, now actually you have a right angle triangle here. So right angle triangle is here. So you can use this triangle to solve the questions, okay, to calculate the angle. So if you plug it out, if you take this triangle out, okay, actually this is what you're going to get. So this is your theta, and then length here, which is equals to 1.7 meter, and the height here is 0.85 meter. Okay, so you have a hypotenuse and opposite. Hypotenuse, opposite, and you want to find the angle at the right angle triangles. The angle theta, so theta is equals to sine -1, opposite 0.85 divided by hypotenuse 1.7. Right? So which then will give you theta equals to 30 degree. Okay, 30 degree. So this 30 degree is located at here. 30. Right? 30 degree. So angle theta is 30 degree. Now that I'm going to expand my equations, how am I going to expand it? T1y will now becomes T1 sine 30 degree minus T2 sine 30 degree minus mg, which is equals to 0. Okay, which is equals to 0. And then, okay, I'm going to plug in the values that I have. So I have 35 sine 30 degree minus T2 sine 30 degree minus m, which is 1.34 times 9.81 equals to 0. Rearrange the equations. T2 is then equals to 8.74 Newton. Okay, 8.74 Newton. So this is how you solve it. So the most important thing in this type of questions is how to find angle. Okay, when it comes to conical pendulum, it likes to ask you to find the angle. Okay, questions seldom give you the angles. You yourself need to find it. It will just give you maybe the radius of the circles. It may maybe just give you the length of the strings and so on. So from there, you need to know how to use trigonometry functions to find out, okay, to find the angles. Okay, next questions. Questions B, okay, just now is B1, now is B2. B2, you want to calculate the net force on the ball. Okay, net force on the ball. So net force is your FC. Okay, the force that causes the object to move. That is what we call net force on the ball. Okay, so summations F. Okay, summations Fx is equals to Fc. So according to free body diagram, the force that is pointing towards the same directions as my AC is the T1x and T2x. So which is equals to T1x plus T2x, which is then equals to T1 cos 30 degree plus T2 cos 30 degree. Given T1 is 35 Newton, so 35 cos 30 degree plus T2, which is a 8.74 Newton, cos 30 degree, okay, which is then equals to 37.9 Newton. Okay, 37.9 Newton. So you can say towards the center. Okay, towards the center or towards the road. Okay, towards the road. So that is your second questions. The third questions, now you want to find out what is the speed. Okay, questions number 3. So you want the speed. The equations that come with a speed is a Fc equals to mv squared over r. But then we got one more questions. If you look at the informations given, we don't have the r. Okay, radius is this the bottoms of the triangle, but we don't have the radius. Okay, you look at the diagram, we don't have the r, but then we can find r. Why? Because we know the triangle, the right angle triangle, where the hypotenuse is 1.7. Okay, and then one of the length is 0.85. So r is unknown. So how to calculate r? So based on the Pythagoras theorem, okay, based on the Pythagoras theorem, 1.7 square is actually equals to your r square plus 0.85 square. So rearrange the equation. R is equals to square root 1.7 square minus 0.85 square, which is then equals to
1.5.
Saya dapat 1.47. Okay, 1.47. So 1.47 meter. Okay, kamu dapat 145, tak ada masalah. Maybe because of the decimal place that you use. So 1.47 meter, that is based on my calculations. So now I can plug it into the equation. So FC, I have just now 37.9. Okay, tak payah kira sudah actually. So 37.9 equals to 1.34 times 1. No, the V is the things that we want to calculate. So V squared divided by 1.47. Rearrange equations. V is then equals to 6.45 ms negative 1. So this is how you solve it. So the crucial part in this question, the key part in this question is actually these two triangles. Okay, this one and also this one. So these two triangles, you need to know how to use them, okay, to find r and also to find angle. Okay, you need the angles, you need the r. So this is what the key part of these questions. If you can understand, if you know how to find angles and also radius, then you should be able to solve these questions. So this question is a bit long. I give you 5 minutes to write it down. Okay, 5 minit untuk kamu buat catatan, including the free body diagrams, the two triangles, one for questions B1, another one for questions B3. All right. So after 5 minutes, we will discuss the last questions. Okay, last questions for today's section. Okay, so soalan ini pastikan Anda faham. Kalau tak faham, contoh dan macam mana cari angle dan sebagainya, pastikan Anda tanya. Right? So this is I think the most difficult questions in chapter 6. Okay, next. So the last question is a conical pendulum case. Okay. The figure above shows a conical pendulum with a bob of mass. Now you're given mass, 80 kg, and then a 10-meter long string. So this is your L. Okay, so don't get it wrong, you know. This 10 meter is not the radius. Radius is from M until the vertical line. This is the radius. But then the 10 meters given is your length, the length of the string. So the angle is 5 degrees, okay? Given angle is 5 degrees. So sketch a free body diagram of the bob. So questions A, I'm going to do it here. So this is a pendulum bob. Now, pendulum bob is an object. Every object comes with a weight. So I have the W that's going down. And then tensions. Tension is the direction of the string, so it's going to work this direction. But then, since you are given angle 5 degrees, you need to label it into the diagram. So this 5 degrees actually is equivalent to the angle beside y-axis. So the 5 degrees is located at here. So this is a complete free body diagram. Okay, where now your AC is going to the right-hand side. Okay, AC is going to the right-hand side because your circular motions is only happening along this plane. Okay, this x plane, the x component. So it doesn't have any angles. It doesn't come with angle. It doesn't involve the vertical component. Therefore, AC is going to the right-hand side. So now I have a free body diagram. Questions B, I want to determine the tensions in the string. So again, I cannot use x component because I don't have the speed of the conical pendulums yet. I don't have the speed of the ball. So what I can do, I can use the vertical components of the free body diagram. Why? Because according to the Newton's first law, summations Fy is equal to 0. I don't need the velocity and so on to calculate the tensions. So resolve these tensions. I then have a Ty minus W equals to 0. So T is cos, sorry. Okay, because angle is now beside your y component. Therefore, for y component, we use cos. So T cos 5 degrees equals to mg. So T cos 5 degrees is equals to 80 kilogram times 9.81. Rearrange the equations. T is 787.8 Newton. So that is how you calculate T. Okay, that is how you calculate T. So B1. Now let's look at B2, the speed. So again, you want speed. So speed only happens on where? On x-axis because A is equal to V squared over R. So for questions number 2, okay, we have a summations Fx, which is equals to your Fc, which is equals to your MAC. X component, now what do I have along the X component? Okay, I have just one force. Okay, I have just one force, which is my Tx. So if you resolve T, you will obtain Ty going up and then Tx going to the right-hand side. So Tx is the only force that is in the same directions of the AC, is a parallel to AC. So Tx is equals to mv squared over R. So T sine 5 degrees equals to mv squared over R. Oops. Okay, over here. Okay, over R. So plug in the value. I have T is now 787.8 sine 5 degrees equals to M is 80 V squared divided by the R. Aha, now I don't have R. But based on the diagrams given, I can find R. Why? Because now I have a right angle triangle like this. Okay, this is a right angle triangles. Angles given 5 degrees. Hypotenuse is 10 meter long. And then we want to find the opposite. Okay, the R. So again, we use a sine function. Sine 5 degrees is equals to R over 10. So R is then equals to 0.872 meter. Okay, so 0.872 meter. So rearrange the equations. Okay. 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 So when you rearrange the equations, you will then obtain V is equals to 0.865 ms negative 1. Okay, 0.865 ms negative 1. And then the questions wants you to calculate again the period. Aha, so we have a familiar terms again, period. So how to link period with velocity? So again, V equals to R omega equals to R 2 pi over period. Okay, so V is now 0.865 equals to my R, which is 0.872 times 2 pi over period. So period is then equals to, yeah, I need a calculator. So which is equals to a 6.33. Okay, 6.33 second. So that is a period. Okay, that is a period. And then questions number 3. Okay, questions number 3. Now it wants radial accelerations. Now, radial acceleration at the same time, it means centripetal acceleration. Okay, centripetal accelerations. So which means you can calculate AC by using V square over R, which is then equals to 0.865 square divided by 0.872. So AC is then equals to 0.858 ms negative 2. Okay, so done. That is a typical conical pendulums questions. Okay, where you need to determine the radius from the lengths given, from the angles given, and then you apply first law to find the tension, second law to find the velocity, and so on. All right, a typical conical pendulums questions. So with this, now we are done with chapter 6. That marks the end of chapter 6. Do you have any questions? Okay, so if no questions, then you just write it down, and once you are done, you may leave the class. That's all for today.